Oh, okay. Yeah,
just
yeah.
to give the
Yeah,
general
yeah.
introduction. So welcome everyone. So this is the Git workshop, just in case you don't know. So the slides for the workshop are in the course website. So if you go to file storage, it says Git workshop PDF. So you can download the slides from there. So we had today Leslie Barnes from the UofT libraries, and Francis, who is going to class today as well. So it's supposed to be very interactive, so there will be parts of presentations and parts of hands-on. So just let us know if you run into any trouble. What else? Oh, we have an attendance sheet going on, so if you don't mind to sign, even if you enroll or not, we can then give you credit for attending the workshop. Okay? So far good. But yeah, okay. You want my screen or?
No, we should go to the first slide. The first thing we need to do is make sure that everyone has Bash. So we have to install Git and also the Unix shell. If you have a Mac, which I see one Mac, you already have terminal, and that's fine. So you don't need to do this.
For many of you are using Windows. So for that you're going to need Git Bash, which means shell and Git.
So can you advance to the next slide so we have the link? So there's the link right there. And so I just want everyone to take a moment and download the program. And if you have any trouble, just stick your hand up.
Oh
yeah. It's to download. So if you're on a Windows machine, you don't have a Unix shell natively, so you need to download the shell and download.
Oh, okay. So if I have like the Ubuntu Bash installed on my Windows, that will work. Yeah, that will work. Yes, I will. Like this color?
Yeah, it's fine. Okay. So if anyone's having any trouble, just stick your pink sticky on your computer.
In the back of your laptop so we can.
And then we can just like come help you. It looks like everyone's pretty much done though. Is this the case? Yes? Yeah, great. Thanks. So can we just go back up a slide?
This one?
Yeah. So I just want to go over that. I just wanted to get the installations out of the way because it's like annoying and not part of the class. I just want to go over the topics. Oh, should I be like doing this?
Oh,
yeah. Slightly awkward. Okay. The topics for today's class. So we already did the installation. We thought that was going to take longer. It took a mercifully short period of time. So we're first going to start just with a brief introduction to the command line because when we're talking about Git, we're going to be using it on the command line. So just some basic commands and just some of the ways in which directories and stuff are represented. And we'll go over that. And then I'm going to hand things over to Marcelo, who's going to talk about Git and using Git on the command line, some of the basics of version control systems, and some of the basic commands in Git. And then last, we'll talk a bit about GitHub and connecting all of this like vocabulary is going to make total sense by the end of this. Connecting your local repository to a remote repository. So that's what we're going to do then. So I'm going to switch to my slides now, and Marcelo is going to show me how. Or to like my computer. Okay. Boop. So everyone's downloaded either Git Bash or you have a Mac. If you have a Mac, go ahead and open Terminal. So you can go to your Finder or your search bar, and if you type in Terminal, you'll see this little buddy down here. The one that I'm pointing at, that's Terminal, and you want to open that guy up. And if you're on a Windows machine, open up the Bash shell program that you just downloaded. Yes, everyone's good? Great. So it should look something like this when you open it. I'm on a different user. It might have a white background, it might have a black background. Don't worry too much about that, that's just aesthetic. And I chose the black background because apparently it's easier to see. It doesn't mean anything. Okay. So we're gonna talk a bit just about command line basics and fundamentals. So we're really just gonna talk about knowing where you are from within the command line, moving around your computer a bit, working with directories and files, and the basic structures of commands. And the most important thing, I think, that I'll be covering this is the basic structure of commands and also where to look and how to look up commands and how to use them. Because you can do some pretty fun stuff from within the command line, and there are lots of resources available for learning how to do that fun stuff. We're doing basic stuff, I'm sorry, but it'll still be good. So the first thing we're going to do is I just want to live code this and for us to do this together. So if you open up the shell, the first thing I want you to do is just type in pwd. So you're going to see this like something with like a number sign, and just type in pwd and press return. So pwd, when you type it in the command line, stands for print working directory. And what it's really telling you is where you are in your computer. So we see, in my case, I have a /users/teaching. So I'm just going to show you if we look at, oh my god, of course I'm going to screw this up. If we look at any sort of file directory structure, it's going to look it's kind of the same thing, but from a different perspective. So here's a picture of me under a different username, and you'll often see a file directory that looks like this. And so the printout we got was something like this, but they're actually just two different representations of the same thing. I'm old enough to remember having to use DOS to use a computer for the first time. Most of you are not. And so the first way I ever experienced computers was like this. So it never seemed so crazy to me, but for a lot of people who have only really used what we call a graphical user interface, this seems so much more intuitive. But really, it's just saying you start at the root, and that first slash means like the very, very beginning. And then you went to a user, and then the user is Leslie, and now you're on Leslie's desktop. And you can see that represented here. We've got the root, and we've got users, and then Leslie, and then I'm in this place, the desktop. A different way in which file directories are sometimes represented are as hierarchies. And so we can see a similar structure. We've got that root, that initial slash, and then a bunch of directories here, and then another bunch of directories inside this one. And so this is just a different way of representing that same idea. Those are the same relationships. And what we tend to call these children, and anything above them parents. So this is like users is a parent directory to these 3 directories. And so if I talk about a parent directory, I'm just talking about going up 1 level. Okay, so back to our terminal. So we've kind of seen where we are. So in this case, I'm in users teaching. You're probably in like user your name or whatever your account name is. But the next thing I want us to do is to type in another command, ls, just ls. Helps if I do it correctly. And that stands for listing. And so now you're going to see all of the directories and or files inside of where you are. So if you were on your desktop, for example, and you were, like me, a very messy person with your computer and put tons of stuff on your desktop, this would be a really long list of things, and it would probably include both folders and files. When I say directory, that's a synonym for folder. It's the same thing. Directories are folders. So I also want us to be able to move around. So we know where we are. I'm in users/teaching, you are wherever you are. But I've seen that within this place, I have this list of directories. And so I want to go into one of them. I want to go into my desktop. So I'm just going to go cd, which stands for change directory. And I'm going to hit capital D, and then I'm going to hit E, and then I'm going to hit tab. And this is a really nice trick. If you hit tab, it'll autocomplete based on file names, and it stops you from misspelling files, which is a very frustrating thing, or directory names, which is a frustrating thing that we've all done many times. And if you just press enter, you can see, and then do that ls command again, you can see the contents of my desktop, which are barren compared to my actual working desktop. So, and here we see I have a PDF and I have a directory. And if we try pwd again, we'll see that that move has now been represented by the desktop at the end. Did you raise your hand? No, okay. When you want to move around within directory structures, you can't move laterally. You have to go kind of back up and back down. And so if we remember this representation, if I were in this Larry directory and I wanted to get into Nell, I can't just go from Larry to Nell. I have to go back up to users and then come down to Nell. Because computers are not intuitive, they don't understand what your yearnings are. You have to be extremely explicit with them. And from here, there is no inherent connection between these two directories. You have to make that link so that the computer understands where you're going. And there are a couple of ways of doing this sort of thing. So back to our command line. I'm in users, teaching desktop, and we see a whole bunch of different directories here. And if I wanted to move into any of these, if I tried to go to downloads from here, first of all, it's not even recognizing it because it's like that doesn't exist here. But it's not going to recognize this. It says there's no such file or directory. Because if we see what's inside this directory, obviously there's nothing called downloads. But if I go cd ... I'm going to go up a level. So ... always means just go into the parent directory. And now we see I'm back up a level, and now I can cd into desktop. Into downloads. And there's like nothing in my downloads because this is my pristine teaching user account. But that moving up and over is really crucial, and it's something we need to keep in mind when we're doing Git, because Git, like the command line, it lives in the command line and it follows that same logic. So being able to move around is really important. Okay. Oop. So one of the, I just sort of want to hit on a general idea within the command line and bash. The general syntax in the command line is the command. So we've looked at 3 commands so far, pwd, ls, and cd. Options, which we haven't looked at yet, but I'll show you one in just a second. And then arguments. And the shape of what an argument is depends kind of on the command you're using. So when you change directory, do cd, your argument is what is the directory you want to go to. That's basically what it is. With different commands, it would be like, what file do you want to do this action to? Or like, what website do you want me to grab things from? But that's sort of your argument, is like, what are you doing this to? We haven't been using glamorous command line commands, so I'm just going to show you an easy sort of option. Since I have nothing in my downloads, I'm going to go back up level, and then I'm going to cd into desktop, where I have things. But now I kind of want to get more information. So I want to say ls, and then this is, when you're putting an option in, people will sometimes call them flags or switches as well. They're all the same thing. And I'm going to do a capital F. And just so that we complete the syntax, because you can do this long form if you want to, I'm going to put the name of the directory I'm looking at. Oh, come on. ls. F. Okay. Anyway, I'm not going to do that. That was a mistake. So here, the F just says, give me a little more information about the files. And the only thing that's changed is we see a dash here, but that tells me it's a directory for sure. So you can get a little bit more information. There are lots of different options for lots of different commands. And we don't sort of have time to fully explore all of them, but they often follow this same logic. And one of the ways to discover different options is to look at man pages. So I'm going to type man ls. And it's going to take me to a manual page within bash. And you can usually find a man page for almost any of the commands, and you can in fact find a man page for git, which will explain you all of the options that are available. On your Windows machine, you're not going to be able to get the man page. So yes, I saw some quizzical looks. And so there's a really great site I really like called ExplainShell.com. It looks like this. Sorry for the blinding white light. And when you put in any sort of command, it'll take you here, and then you can click on it, and you can see all of your options. And it'll just give you an explanation. And it's a really great way to learn more about different commands on the command line, or if you're ever confused about it. This is a really great resource to just read through and see what you can do. And it'll often give you pretty full definitions. So if you're curious about learning more commands on the command line, I really encourage you to either just dive into man pages or use ExplainShell. And another thing I always, and I feel is very strongly about the command line, is just Google aggressively, semi-aggressively. You're inevitably going to end up at a place called Stack Overflow. This is going to happen to you. And you're going to discover that half of the people at Stack Overflow are jerks, and the other half are really nice people who can answer questions. And ignore the jerks and read the answers to questions. You're going to learn a lot in places like Stack Overflow. And I'm not by any means traditionally trained. My undergrad and graduate degrees are in English. I learned everything by Googling. There's no requirement that you have to go to a coding class to learn these things. You can just learn it online, and just be bold about it. The only command line command I'm going to ask you to exercise caution with is rm. and that is remove. And unlike when you're on your graphical user interface, when you delete something and it goes in your recycling bin, and you can retrieve it from your recycling bin if you think you made a mistake, when you remove something on the command line, it's gone. Like, it's not coming back. It's very deleted. Like, there's nothing to do. So don't delete stuff like using that a lot, but almost everything else you can do on the command line, you're not going to like break your computer or anything. Just play around and have a good time. One thing I want us to do in preparation for, and to exit man pages, press Q, which stands for quit. One thing I do want us to do, because we're going to be using this for an exercise later, is one last command, and that's make directory. And so I just want to see where I am right now, so I'm typing pwd. I'm on my desktop, fantastic. And so I'm going to mkdir, which is the command, and then I'm going to just name my directory. So I'm going to call it git demo. And I'm going to press return, and then I'm going to ls, and we can see that my directory has appeared. And if I go into that directory and ls, we can see that it's empty, because I haven't made any files, so it stands to reason that it's empty. So that's sort of it for my extremely rapid introduction to the command line. Does anyone have any questions? No? We're all good? Cool beans. Then we can start talking about Git. You want the other thingy, right? By which I mean the other computer. You're good? Okay.
I just need the mic. Thank you, Leslie. So how many of you have used the shell before? So you're quite familiar, but if you have any questions, I think Leslie covered in a good way all what we will need for today. So what I'm going to do now is I'm going to start talking a little bit about version control and Git. Okay, so let me start with version control first, because what happened is that actually Git is just one program, one tool that implements version control for you. So in a nutshell and very quickly, what is version control? Well, it's a tool for managing changes, and this can be in a set of files, and I'm being very generic here, so I'm going to start from very generic up to then do a particular demonstration. But the point being is that you can use this for any kind of files. It can be programs, it can be papers, it can be your documents, it can be basically anything. Depending on the version control system that you use, depending on the version control program that you use, it has more advantages doing in a particular type of file than in other types. Like if you use text-based files like programs, let's say papers written in LaTeX, if you know what I mean, those kind of things, they have a little bit more advantage than just using Word type documents or Excel sheets or those kind of things. But it doesn't mean that you cannot use them, and I hope I'm going to show you an example that will resonate with some of you. If you're not familiar to coding, it still is something that you can still use it. What version control basically aims to is to keep a track of changes as time passes. The main difference or the main thing to consider here is that you need to be explicit of when to take these snapshots, these points in time where you want to keep record of those changes. And that is the things that we are going to be doing today. As I was saying, can you think of any example that may resonate or be, it may sound familiar to you based on this? Any program? No? Nothing comes to mind? Yeah.
I mean, anytime you're collaborating on anything.
Correct. And this is what I'm after. Sorry. This is what I'm after for So if you use Google Drive, basically you have a collaboration tool, and you can see, so this is what we did with Leslie. We were collaborating in the slides for the workshop today, and you actually, if both of us are logged in the Google Drive at the same time, you can see that she may be working in some slides, I may be working in other slides. So that is a collaboration tool. A different way or another tool that kind of follows this idea is Word, or any kind of Word editor, and especially if you have this track changes feature activated, you can see how the document changes and the suggestions that your collaborators do during the creation of the document. There are other things like Dropbox, and other tools that you can claim has kind of these features. However, what I'm going to claim is this is not version control per se. And the reason is, take the Google Drive for instance, if we are creating the presentation, how can I go back to X point in time? I don't have that history, I don't have that guideline to tell me, okay, in version 7 of this document, you did change this. So that's why I don't like to call this really version control systems, but anyhow. So another reason why, and this has happened to me, and betting happens to many of us here, is you try to keep changes in your files and don't lose it, right? So one way, and I have done this, I have to admit I have done this, I don't do this anymore because I use Git, but I have done this, is start to create copies of this file. So I put, okay, this is my data, or this is my program, and the dates, and so I try to keep those changes. So if something breaks, or if I make a modification, or I don't like it in a manuscript, I can go back. Now the problem with that is then, as you see in the right, you end up with a list of many files, and at some point, again, you keep those changes, but you don't keep the flexibility of seeing difference between those changes, especially if you are looking at files and large files, you don't have that feature anymore. So that is kind of the problems that version control in general tries to tackle. So a little bit of a teaser, why using version control? Well, makes collaboration very easy. I usually use version control for anything like papers, creating slides for lectures, programs, almost anything. It helps you stay organized. So instead of having these 10 or 20 files, replicas with different timestamps, I just keep one file, and the version control system will allow me to look into all the changes as time passes. This is important, especially for science, allows you for reproducibility, because if I have a program, let's say, and I made a change, and I have some results, and now my results from the previous version of the code doesn't match the ones I have right now, I can go back and try to reproduce my results. When something goes wrong, in particular if I introduce a bug or my program doesn't work anymore, or I deleted accidentally one paragraph that my collaborator wrote, I can go back and recover that. As I mentioned, it can be used for writing code, writing papers, and it's especially useful when you have test-based documents, means that the version control system will understand the changes and compare head-to-head what happened there. In addition to that, if you're interested in professional software development or data analysis, this is one of the must that you have to know. So it's considered a must in professional software development and data manipulation. I mentioned this to you already. Any questions so far? So I haven't talked about Git at all. I just mentioned the generalities of version control, and I mentioned this because there are many different programs that can do version control for you, and the one that we are going to talk about today, because it's one of the most popular ones and probably one of the most used ones, is Git. Git has an interesting story because it was created by Linus Torvalds. You know who Linus Torvalds is? It's the creator of Linux. So it's the same guy that created the Linux operating system, and at that time, I think it was 2000 something, there were other version control systems, but Linus is a very opinionated person. If he's around, and you can see some tech talks even from him, he thought, okay, all the tools that are right now don't please me, so I'm going to create my own tool, and that's how Git actually was born. Yes?
I couldn't agree more with you. We had a kind of a key phrase that we always like to see and say in our programming courses: don't reinvent the wheel. But I had to take an exception with this guy who is the creator of Linux, right? So I was like, he did a pretty good job. And I think the reason why he created this program, this tool actually, is because he noticed that some things were missing. So just to mention some of the examples that were at that point, SVN, which stands for, I don't remember, subversion control, and CVS, concurrent version control, were kind of centralized repositories. We are going to talk a little bit in a second what a repository means, but they were centralized engines of version control. In some way, Git removed that constraint and also allowed to much powerful things to implement. So I hear you. I agree with you. Maybe creating something from scratch at this time. But sometimes there is a tool that is missing, and it's not always a bad idea. Absolutely. 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 There is, in life usually there is no black and white answer. There is all a degradé of options in the middle, and probably this is one in the gray area. So definitely, yeah. But still, it's a funny story. And actually, if you ask me what Git means, I don't think anyone knows, because it depends on how Git is behaving. So this is a caveat that Git has, because it's a really powerful tool. It brings a lot of new elements, but also it brings some complexity to it compared to the other version control systems. So if you want to know about the naming of Git and what people interpret Git means, go to the wiki. I'm not going to tell you much about that. As I mentioned, Git is one of the implementations that are around nowadays. Is the most popular one, I think. Just to give you some names, CBS and SVN were other ones that were a little bit old. Another one that some people use is Mercurial, HE. That is a Python base, and actually it comes with Python, so some people like to use that. Sun IDEs, which stands for Integrated Development Environments, has the ability to incorporate version control directly on their platforms. So if you take, for instance, RStudio, you can indicate RStudio what version control program you want to use. So you can actually indicate either SVN or Git, and it will allow you to kind of automatically follow the changes that you are doing. I believe Xcode, which is the IDE for development in Macs, also do that. And I imagine that the one in Windows, which I forget the name now, also allow you to do that, because it's, as I say, it's one of the tools that are in your box when you are developing codes. And as we're going to see later today, there are also very nice web interfaces that allow you to use version control in an easier manner than what we're going to do initially in the term. So, how many of you have used Git or any sort of version control before? Okay, a few of you. So I'm going to just revisit the main concepts, and this is my own diagram, my own interpretation of what is going on with Git. It's completely oversimplified, but I think it's kind of representative of what actually happens behind the scenes, at least at a very basic level. So what I have here is a space-time diagram. So the horizontal represents your computer. So this, all what is in there is your computer. This is time as passes by, and the dots means whenever I have a different version of my program, of my file, or something. So this arrow here represents your hard drive. Like Leslie was mentioning, we created this Git demo work directory. So this is going to be my local directory. So this is the data that is in my Hydra. Now, Git has a particular feature that is a little bit different from other version control systems, and is that it has a two-stage process for committing a version to the history of the changes. We are going to see this in the practice, but basically I can add one file when I do a modification to the file, and that goes into what is called a staging area. It's kind of mean that I'm interested in tracking this file, and then comes the actual commit. So it means if I had a version, I start with my version of the code, then I do git that, and I keep that file in mind. I'm going to follow the file, and then I do git commit. And what happens is, we're going to see this in a second, Git is going to create a hidden directory within that directory where it's going to keep track of all the changes that happen to the files that I decide to follow. So what happened then is create what is called a master branch, and we're going to go through the shell in a little bit, where it stages, or where it keeps the version of the file that I just commit. So that is my first point in time where I have an image of the original file. Let's say then I do a change on that file, I modify something, I find a typo, I find a bug, I add that file to my list of staging files. I keep working on the file, so I can do also another modification, add the file again to my list of wishes if you wish, and then commit that final modification to the master branch, to the actual repository. So this is more or less how the gymnastics of Git is going to work. The idea is, if you don't have Git at all, you won't have that white box in your directory, and you only have the files, but you don't have the ability to go back. Because you have this master branch, then you can jump between the different commits and the different versions of the file that you had done. Okay? As I say, it's a little bit picturesque, but I give you a little bit of what is going on. In some cases, if you don't see this picture, it may feel like Git works just by magic. What happens is every time you do these gymnastics of adding files and committing, there is an image of that file that is recorded in the log, in the history of changes, and that's how Git can go back in time and recover one previous version. Yep. I can create multiple files, or I can, you mean in the Git directory? What happens is a little bit more complicated. That's why I mean this is a very oversimplified diagram. Let's say that you have a 1 megabyte file, and you make a change, and you commit that, and then you do another change, and you commit that. It is not going to keep replicas of those files. It keeps tracks of the changes alone. So in that way, it saves space. There is, of course, the overhead of the first time. So at least you have twice the space that you will be using, but the changes don't count. Like if I have 10 commits, there won't be 10 times the space. It's just the initial commit and then the changes, the relative changes between the files. No, and we're going to see that in a second. What will be different, though, is a sequence of characters, a label that Git is going to generate for you, but that will be tied to the commit and to a message, a representative message, a meaningful message that you will give to the commit. So all is tied together in such a way that I can go back in time, and if I was careful enough in how I name my commits, I can recover exactly depending on what change I did. That's a really good question. Any other questions? I know it's a little bit theoretical so far. We're going to get our hands dirty with this. Just a little bit of the gymnastics. So I was mentioning this. This shows a little bit of the collaboration and how the changes and the revisions that one can do in the files may work. And again, this is a very simple example. It's just a shopping list. So, and it's supposed to be showing by pieces, but doesn't matter. So let's say that we start here. So this thing that we have, this box, is usually referred as the repository, because it's where you save your files, but also where you keep track of your changes. So allow you to repose, I guess. So let's say we start with that, and we have two persons working in the repository, Chef and Dan. And let's say that someone checks code into the repository, while another person is working a second version of the code, or a different version of the code, and also check the changes in the repository. And finally, that other person can take the new changes and modify. So one of the features that we're going to see, or we're going to mention at least of Git, is that allow you also to collaborate, because it has this integration tool that basically allow you to merge, to combine changes from two different collaborators. how it works is in the following manner. If you have a long file and someone is working, and let me take the example of a paper, it's cleaner, I think. Someone is working in the introduction of the paper, someone is working in the conclusions of the paper, then that is easy for Git because the parts are disjoint. So basically it looks at these two pieces and then they merge it. Let's say that in another case, someone is working in the methods and someone else is also working in the methods. Well, that part is a little bit more tricky, but Git also will try to see the changes. They will try to see if they don't overlap, then it's similar to the previous case. If they overlap, it will tell you, well, you know what, someone else was working in that version of the file at the same time in the same part, and it will highlight the changes and I will allow you to pick which changes you want. In some cases, like the previous ones, that is basically easy to solve with Git. In other cases, it may be a little bit more complicated, but still you have some tools that allow you to help with that. The other thing to keep in mind is, I was mentioning this master branch here. It's called master branch or main trunk, however you want to call it. And this is one way you can also visualize this. That's the shopping list example. So let's say that one day I ran out of milk, so I add in my shopping list in the door of the fridge milk. Second day I ran out of eggs, I add that. So that will be my second revision of the shopping list. Third day I ran out of orange juice. That's my third revision. But what may happen between day 3 and day 4, or version 3 and version 4 of the shopping list, is that I stop by the supermarket, I buy orange juice. So when I arrive home, I say, okay, I don't need orange juice anymore. I cross out orange juice from my shopping list. But at that day, I imagine I want soup, so I can add soup there. So the way that it will work with Git, if we want to represent this, is I take revision 3, I cross out orange juice and I add soup, and I check in, I commit my changes, and that is revision 4. Now, because I did this, I also had the feature that I could go back to revision 3 and revert, or my working copy, if you wish, and revert to revision 3. So that is kind of the things that will allow you Git to do. Now, this is not free, in particular if you're doing it in the command line interface. You need to be very diligent in committing each of the times that you change the shopping list. So that is one of the things that at the beginning it's hard, but every time you do a change in the file, you get used to add the file and commit, and that's just it. Okay, any questions about it? All right. So I mentioned a little bit of the shotgun, and I promise after that we are going to start doing something in the terminal. So the repository represents this kind of unified space where your actual files are, but also this directory that Git will create, and there is a lot of things there are going to live, so that Git can actually keep track of the changes and allow you to go back in time to different versions. Check-in and check-out represents these actions of, okay, I modify my file, but if I don't explicitly tell Git, commit that changes to the repository, that won't happen. That is a check-in. A check-out is, and we're going to see that more clearly when Leslie show you how that works with remote repositories. So far, in the diagram that I'm showing you here, everything is local, everything remains in your computer. Now imagine that this computer is not your computer anymore, it's a web server like GitHub or GitLab, where you can host your Git repository, and then you can have different users accessing that. Well, in that case, I don't know what anyone else has been doing, so I need to recover the changes from that repository for starting to do mine or merging with mine. So that is what a checkout means. It means go to a central repository and get the changes from other users from that repository. Branches is one of the most powerful things that Git offers, but it's also one of the most complicated ones. And the reason is, imagine that you are working, and again, I can take the example of a paper or example of a code. Imagine that someone is writing a version of a paper that you want to submit to a very prestigious journal, and you say, okay, you know what, I may want to take a different approach on that, but you don't want to overlap with the person that is writing the main paper, so I may create a branch, and a branch is nothing less than a mirroring at that point in time of the version of the paper, and you start to work in parallel in a different approach to that paper or to that code. What may happen then, this is very it's not much use in papers, especially when you fight a lot with your collaborators, but a lot with code and programs, because if you want to add a new feature to your program, then you may say, okay, I'm going to work in feature X, that if it works nice, then I'm going to put back in my main program. So you start a parallel version of that, you play with it, you implement, you test it a lot, and when you're happy with that, you put it back in the main trunk or the main repository. The revisions are nothing else than the different versions in tag. Yes, please.
Have to come back to the main?
No, not necessarily. If you look at some serious packages, what happens usually, and that's something that you usually like to do, is to keep a main trunk, a main repository that is the releases, the official releases, and then have in parallel test and development or checking and development branch where I try a lot of things, and you can keep that, and you can do vice versa. You can commit things from the development branch to the main repository, or basically if you want to keep your development repository in synchrony with your main repository, you can go back and forth, but you don't need to merge it necessarily. So revisions are the different timestamps or the different commits that you have in each of the branches. Commit is the process of actually taking one of the changes and putting it back in the repository, so creating that timestamp that you can circulate the enter. And conflict is one of those cases where you are working in a similar paragraph or a similar part of the file as someone else, and then when the differences are such that it cannot be resolved automatically, it calls them conflicts, and you need to go and look at them manually and try to fix them. And there are a lot of more of terms, but I just mentioned here the most important ones. Okay. So let's start by creating a version control repository a la Git, let me say. So the first thing that you need is to set up Git in your computer, and that was part of the thing that we did initially today, and that's why we suggested that if you were using Windows to use Git Bash, because it brings both things together, shell and Git. If you want to test that you actually have that, one thing we can do, and let me see if I can bring one of my terminals here, is you should type Git in your prompt. Let me see if I can make this bigger. Everything, and instead of getting an error message like command not found, it should tell you all the possible options that you may find or all the subcommands that Git has. So in a way it was very similar to what Leslie was mentioning today about having a main command, in this case is Git, and then instead of flags, which also Git allows, you have subcommands. These are called subcommands, and those are the ones that we are going to be using for doing the different parts of the different stages that we have in the repository. So I invite you to try that in the terminal if you want to follow along, and if you hit the command not found, let us know so we can help you to set up Git if you don't find. Okay. Let me see what else we have. So these are the usual steps that you do. So one thing to keep in mind, and that's kind of also what I had my diagram here, is you will have, or you can have, one repository per folder. So you can have many repositories within your computer. Okay. You can even have repositories within repositories, but that is complicated. But in principle, let's say you can have one repository per folder at least. Okay, so that represents one folder in my computer, so I want to create one repository there. So you can have, so whenever you do want to do that, the first thing you need to do is to initialize the Git repository, and that you do only once per project or per folder, as I was saying. And then points 2, 3, 4, and 5, you repeat as many times as you need. So you commit files into the repository, you modify your files, delete files, add new files, and after that you commit the changes and you repeat as needed. Okay? So I'm going to show you some examples now how to do that. You can follow along this example so we can do the hands-on together after seeing the examples. So the first thing I'm going to do, for instance, is I'm going to create a new folder. Actually, Leslie created one called Git demo, so you can use that one if you want. But I'm going to say enkidir. So by the way, this usually what comes before, and this changes from computer to computer, right? If I show you, this I think is the Ubuntu subversion system in Windows. So whatever comes before this blinking part is what we call the prompt. And it means it's all information that the computer is telling you where you are located, and then the blinking thing means I'm ready for your commands. So you type whatever you want there and hit enter, and the computer will try to interpret that. So in this case, I'm in a computer called my computer. I have a slightly different prompt here, but I'm going to type one shell command, which is create directory, mkdir, and then my new repo. So I'm calling this directory my new repo. Then I'm going to do cd into my new repo, and my prompt changed to indicate that now I'm located in my home dir, so the tilde here represents my home directory, and then my new repo. And the third thing, so this is a step 0 or step 1 if you want, and this is the one that you do once per repository that you create, is type git space init. So git command, the subcommand associated with git is init, and this is the message that you will get. Initialize empty git repository in wherever my new repo and .git. Okay. Now what this means is Git has created, this white box for you in that directory. So that directory contains now a Git repository, and it's telling you where it's located. It's located in this .git subdirectory. And actually this .git subdirectory has many other things, and we're going to take a more careful look when we do this live. But basically you do ls, and then we use a special flag. In this case, Leslie was showing you -f. I'm going to use the -a, which means show all the files there. Usually in Unix or Linux, the extensions don't mean much. But when you have a file or a directory that starts with a dot, it means it's a hidden file. So if you want to see that one, you need to add this -a flag. And then it will show the dot represents my current directory, 2 dots represents the upper or further directory, and then .git is this hidden directory that Git has created for you. And I will show you later, there's a lot of things there just to follow all the history of all the files that you have. Okay? So, first step, create your directory, or you can have a directory already that you want to put under version control, sit into that directory, type git init, nothing will be deleted, but a new directory, a hidden directory called .git is going to be created, and then you can start to add files in there. Okay? If you don't have that, and you try to do all the gymnastics that Git implies, you will get an error message saying, okay, this is not a repository, so I don't have a place where to put your changes. Okay? And this is a common thing that happens, especially if you are navigating your directory tree. You may be in a place where you forgot that it's not a Git repository, so you try to do that. So the other thing that may happen, and this happens usually the first time that you use Git in a computer, is because Git is very peculiar. It wants to know who did that and when you did that. So it needs to know who you are. So the first time that you're going to run a git commit command, it will tell you, or it might tell you, please tell me who you are. I'm not kidding. I copied this from the output of Git, and I hope that we may, in some cases, you may see this for yourself. And the only thing you need to do is actually follow the message that it gives you. You run git config, and I tell you what --global means. So this is a flag, and then says user.email, and it waits for your email there, and git config --global user.name and your name. So the --global means for whatever other repository you are going to create in that computer alone, is going to always use those credentials, your name and email that you indicate in the previous lines. If you don't want to do that, for instance, if I have collaborators that work at UofT and I want them to see my UofT email, I have collaborators working in Europe and I don't want them to see my UofT email, I want to send my Gmail email, then what I can do is in that particular directory just use git config username and then my name, which you should say there, and then git config user email and my email there. Okay? this is more of a warning. In some cases, depending on the operating system and depending how Git was installed, and depending if you use Git before and depending if you set these commands, it may take your name and your email from your own user credentials. Okay, but it's most likely that it will happen if you haven't used Git before. Okay. Yes.
What can you ask it, but it's currently using?
Yes. So if you just type git config username or git config user email, it will tell you. It will tell you directly. So for instance, if I go to, let me see, let me try this. I think I call my new repo. So I'm going to start following my slides. My new repo. So I'm in my new repo now. If I do ls-a, see if I can. You see there is the dots and then dot here. Nothing else. If I do git init, now my repository is initialized. So that's a great question. So how can I know which credentials Git is going to use? Well, I can do git config and then user.name and nothing there. So it means it hasn't been set up. And the same thing, I can do git config and user.email and it's empty. Sorry? Like that?
No.
Oh, okay. I didn't know that. Like that?
So that'll
Okay, that tells you all the things, and there is no information about the user. So I prefer the other one because it's more like pick point to the credentials. This gives you a lot of other information. But now that we are here, and I'm jumping ahead with the hands-on session because the other one I found to be like, we can go back to the slides, but it's a little bit dry, and this way if you guys want to follow, we can play along. I just created a directory and initialized the repository, nothing else. But if I do ls-a now we see that .git the repository is in there. What I'm going to do is I'm going to take a peek at whatever is in there. So I'm going to do ls, and I will keep my -a just for convenience, and then .git, which means go and list whatever is inside the .git repository. And now you start to see that there is a lot of other things there. Actually, I want to add one more flag to my list of flags for the listing, which is -l. So that gives me a little bit more of information. So who created, so in this case, this is kind of Linux standard convention. So the first thing is permissions that you get into the file. Don't worry about the next column, but then comes the username and the group. In this case, signed is the username and the group at which signed believes is signed, and the time it was created. But now you can start to see what Git is tracking. It's tracking the branches as we talk. So in this case, there won't be any branches yet. There is a config file. I'm going to show you that in a second. There is a description file. There is a head that points to what is the current pointer to the history of Git commits. This is just initialized, so it must be empty. And then there is a lot of other things, hooks and information. So as I told you, Git can get complicated, but it's very powerful. So all these things are needed in order to make Git work as it does. One thing I want to show you, and I want to be compatible with all the OSs. So you guys remember if Git bash has cat or more? Let's try. Okay, I know it has less. So less is another command from the terminal, from the shell, that allow you to see what are inside files, in particular text files. So what we are going to look is at the git config file. So I'm going to do less.git because it's where the config file lives, and then do config. And you can use the tag completion as Leslie was mentioning. So if you do that, it's going to show you a little bit of information that the repository contains. It's kind of cryptic, I have to tell you that, but basically you can add more information here to configure your repository as you wish. Another one that is useful, and for exiting you press Q as with the man pages for quick. Okay? The other one that is useful is the description. And so basically that allows you can change this file actually to give a more meaningful or sensitive information to the description of the repository. In this case, it's an unnamed repository, so you can basically, it's telling you edit this file to name the repository. So I can do that. I'm going to use one of my favorite editors, VI, but probably no, let's not use VI, it's too complicated. Let's use Nano. So Nano is another text editor. I'm going to delete this whole thing, and I'm going to call this repository a testing repo for the Git version. Okay, and I'm going to save this. If you're using Nano as well, you can do Ctrl-O, and it takes by default the name of the file. So you hit enter, and then you do Ctrl-X for exiting. And now if I look at the description again, it says testing repo for the Git version. And you can name your repositories as you wish. Okay. All right. We haven't done much with Git, but now I'm going to do the configuration I was telling you, because if I do the git config username, it's empty. So I'm going to config to add my name to this repository. So I'm going I use the same command, git config username. In this case, I'm going to write my name. Okay. And if I do the same with my user email, it's still empty, so I'm going to put my email address there. Okay. So now if I ask for my user email, now it says the email address is using, and if I ask for the username, it says the name of the person who is using. And actually, if you wonder where the things are stored, we can go back to the Git repository and look into the config. And now what happened is, I don't know if you noticed, this section that starts with bracket user was added, saying the name of the person who had the config username, and then the email of the person. So that is all that, where all that magic, between quotation marks of course, is stored, is within that hidden directory, that .git hidden directory in that particular folder. And as I say, if you want to create a different one, then you can go to a different directory and change this either on the config file or with the git commands. Okay. Any questions about this? No? Okay. So that was a little bit of the configuration. So coming back to the slides, I have some examples of how we can create some data, and we're going to follow this in a second. But basically what is going to happen next is how we are going to add files to this repository that we just created, how we are going to modify these files, and how we are going to notice differences and do the gymnastics of committing things and so on. Okay. So let me do that. So I'm going to mimic the creation of a file, or let's say that you receive data from a lab or an experiment, and you want to put that data into the version control repository you just created. So one way to do that is I'm going to do the echo command. What does, if I say, let's do the mandatory hello world example. If I say hello world, whatever it does is just it puts in the screen whatever I type there. Okay. Now there is something very useful and very powerful. Let me do the hello world example again. In Linux called redirection. So I can use the greater than symbol and put that into a particular place. Instead of being displayed in the screen, I'm going to put that into, let's say, a test file. And test file is a file that doesn't exist or didn't exist until a minute ago before I hit the enter. But if I do ls, and I like the -l because it allows me to see more information. Now I see there is a test file there. And if I look inside the test file with the ls command, now it shows what I wrote before in the echo command. Okay, so redirection is a very useful way to create very quickly files in the shell, or to capture the output of a particular command and put in a file. Okay, you can do this with ls, for instance. If I do ls, and let's see that we want to keep track of whatever is in the Git directory, I can put this into git.content. Okay, and whatever ls was going to produce, if I don't run this with the greater than symbol and I just run it in the terminal, it lists all those things. But now if I look at the file we just created, git.content, now whatever was the output of ls was dumped, was saved into that file I just created. Okay. So, you know what? I think I'm going to stick with this example. I kind of like it a little bit more. But I'm going to do one more thing. Going to do -L and then -R, which is recursive, and I'm going to look at the current directory. So if the current directory should contain my Git content and my test file. It's not going down. Why is it not going? Oh, I know why. Yeah, okay, let's do that. And I'm going to put that into current here. Okay. So right now I have 3 different files. I have my current dir, I have Git content and test file. Okay. Now let's say I want to keep track of whatever test file has. So I told you there are 2 steps that are needed in Git to put that file into the repository. First one is to do git add and then the name of the file. So I'm going to do test file. Okay. Now there is another command I want to show you using the list of commands later on in the slides, but this is a very useful command, at least for me, because I told you there are 2 steps every time you want to create a commit. If you are not sure if that file is committed yet or not into the repository, I can do git status. So git status tells me about the files that are in the current repository, and it tells me, okay, there is a new file called test file, but these changes need to be committed, so they haven't been committed to the repository. This file is not part yet of the repository. It's in that wishing list we talked before. It's in this staging area, but it's not in the repository. So I couldn't go back and recover the version of this file as it is right now. Okay? And then there are untracked files. This means these are files that are in the current directory, but not in the repository, because I didn't add them to the repository. Okay? So how I do that? Well, I'm going to first commit. I'm going to commit, and this is the way it works. So git commit, and then you do -m, and then between quotation marks, you write a very meaningful message to identify what that commit represents. So in this case is my first commit of the test file to the repo. And now what git replies is the name of the or the message that you give, and says one file change, one insertion, because you add one file, and then it's something about the permissions of that file. So you don't need to worry about. Yes. Yes, absolutely. Absolutely. If you want to do that, you do git add dot. I'm not going to do that because I want to play a little bit more with the files, but that will commit all the files that are in the current directory. Okay, and then of course you need to do the git commit thing. Okay, why I'm insisting with the messages and the -m and being very meaningful with that, because then the other command you can try is git log. So git log now will tell you, okay, this is the commit that you just did. This is how Git identifies that commit. So it's a very long sequence of numbers and letters, but it's unique, and that is how we can keep track of infinite changes almost. Who did this commit? That was why Git was asking who we are, name and email of the person, when the commit was done, and the message associated with that commit. Meaning that if you put a really meaningful message here, you can actually pick point by basically connecting the label with the message to the particular release or version of the file that you changed. Okay? Questions about this? I probably should. I don't remember if we had that, but I'm going to do this live. I'm going to put a list of the commands that we are using here. So git init was for initializing, git config, and then username, and git config user email for either setting or exploring what the credentials were. So these ones you actually do once per repo, and then updating the repo will include git add and then file name, git commit -m, and let me put meaningful comments. And we are going to keep updating this list, but this is the list of commands. Oh, and then git status, and I show you one more in a second. So this is for querying the repo. And I can add this to the slides. I thought I have it somewhere, but I think I have it, but not in such a ordered list or something. Okay. Yes, sir.
That string last. So if we were to add
Correct. So one of the is a feature, but it's also some people like to do it and some people don't. I give you an example in a second. So I think what you're saying is I can do several git adds, right? So I still have 2 more files here which are not in the repository, and I can see that if I run git status. Now notice that before, let me see if I can go back. So that was my first git status, and it's showing green that there was a new file, but it wasn't committed. If I run now my git status, it doesn't have that green name, but it says there are 2 files that are still not part of the repository. So I could do git add dot, which it will include all the files, even if there is a change in the file that is in the repository, or I could do git add, I could say git add current dir and git dot content, right? And hit enter. I'm not going to do it, and then do a commit. Disadvantage of this is now these 2 files are part of one commit. So if I did change something, or let me rephrase that, if I want to just recover one of these files, then it's just one commit. I cannot do that. Okay? If I go back to that commit, I recover 2 at the same time. Why people may want to do that? Well, sometimes it's simplicity. Sometimes it means that the change that you did in the files are entangled somehow, and you don't want to, break anything. Like if you broke something, you want to go back to both images. It's true you can do a more fine-grained commit, doing one by one. At some point, it's a little bit personal, right? It's like commenting code. How much commenting or how less commenting you need is a little bit up to you. Yeah. No, because what I was mentioning before, it keep changes in an incremental manner. So only the differences with the previous version. Meaning that if I do a git add in a file that it hasn't changed, actually won't commit it. Git is smart enough that it can compare the content of the file, and if nothing has changed, it won't commit it. Yep.
Other ways.
I don't think there will be much different. Maybe Ramses can say something about that, but I won't think there will be. It will be what the only difference is in your log or in your track of changes. There will be 2 more entries, but those are completely like bite-sized changes, I would say. Yeah. In one way, Git is very efficient on that. So one thing I discovered, like by using Git a lot, is that if you change the permissions of the file, so if you change a file that is executable or not executable into executable, Git will pick up that, and that is a commit. But this maybe 1 byte that we are talking about, no more than that. Any other questions? You guys trying this? Are you playing around? Okay. What else? Let me see what I have in my slides, because I went out of row here. Okay, let's say that now we're going to change one of the files. Oh, one other thing I want to show you, this is also, I found it useful, especially when you had a big repository, is this other command, git ls-files. And that will list the files that are actually in the repository. So in this case, we have just 1 file. So I'm going to add that to our list of git commands. So git ls-files. Did I put git log here? Git log as well. And now I can see there is only one file in the repository, and it's this test file. Okay. So you don't remember what that test file has. Oh, it has hello world. Okay, so I'm going to add something to that file just to show you how the difference will show up. And instead of saying hello world, I'm going to say adding some data. And now instead of using the greater than symbol, I'm going to use two greater than symbols, which means add this information to an existing file. And I'm going to take the test.file. Okay. Now if I look at what the test.file has, now it doesn't only have the hello world line, it also has adding some data. Okay, and usually the way it goes, especially when you are collaborating with other people in the repository, this is what I do. Or if I have been working in other project and then I come back to this one, and I don't remember if I did commit my changes or not, first thing I'm going to do is git status. Now git status, if you remember from before we changed the file, it was saying only that these two files were not part of the repository. But because now I modify it, a file that was part of the repository is telling me changes not staged for commit, which means this file has changed, and it says modify. Okay, it still shows the other ones which are not part of the repository, but it's showing in particular the first one, which is the one that has changed. So that I do with git status. Then if I want to see what are the difference between the current version I have of the file and the version I had in the repository, what I'm going to do is git diff. And now git diff is going to tell me in a kind of cryptic manner. So the first file is the file that is in the repository, the second file is the current version of the file in the directory. Is okay, your previous has the line hello world, and now you added, that's why the plus sign, a new line saying adding some data. Okay, so I'm going to add that to our list of commands. So git diff, and I can be more specific. Let's say I had 200 files, and now it's going to show, if I just do git diff, it's going to show all the files with differences. But I want to be very picky on the file that I want to see. I can do test file, git diff, and the name of the file, and it will only show the file that has changed. Okay, so again, in this case, it's kind of trivial because we have only one file in the repo. But if I had, like, as I say, many files and several of them has changed, it will try to dump all the differences. So if you want to go one by one, you can basically do git diff and the name of the file. Yes?
Getting a warning message. LF, CRLF.
I think this is because an encoding in your text editor. Are you using git bash? Yeah, don't worry about that. We can take a look in the break, but I think it's just an encoding thing. And encoding means something that is using the computer to represent. Actually, if I understand it correctly, what happened is the return statement, the new line character. So if you look at a file, is actually a linear structure. But when the computer represents that in the screen, it needs a special symbol that tells, okay, go to the next line and display the next line. Depending on the OS that you use, it in Windows, Linux, or Mac, the symbol they use may change slightly, and that's, I think, is the warning that you're getting. So CR stands for carton return or something, which is the old way that we had in the typewriters to say go to the next line.
It actually says the file will have its original line end.
Yeah, so it's okay. You don't need to worry. It's just something with the encoding. Okay. Any other questions about this? So how do you think I should do to update my repo with this new file? There we go. We have done that. So I'm going to do git add. The name of the file is test file. Okay. And of course, git commit. And I'm going to try to be meaningful, mimicking that this is new data that I received from the lab and I want to update my data file. So this is new data received from, I don't know, Ryerson's biochem lab, adding to my data file. And a lot of typos there. Okay? Yes?
Since you have old work file here.
If I want to, if I don't do the add, the git commit won't find what to commit to the repository. What you can do though is you can, some people like to do that, I think Francis does that, is to combine both things together. I think it's git commit -a or something like that. So you do the both steps in one. So that is possible. Don't ask me why, maybe I like to type things in the computer, I like to separate them, but if you are committing one file at a time, that is completely possible. Maybe you have
decide. So, is it? Don't. For instance, you have a value. Someone's out. Don't want to. Still put it at. Here's out at under. Both files it. On added. I never see it. And change file. And all of these files I already have files.
Did it answer your question?
So
Okay.
what you did to change modify voice like file.
Right. Yeah. Okay. So, and if I do git status now, it just says these other two files are still there, and you know, if you want, you can add it or not, but it doesn't say anything about the test file. Now, there's one more thing I want to show you. Now, if I do my git log, there are two entries here. My first commit, and this is in chronological order, so the first ones that come, the first that comes are the latest ones, and the last ones are the first ones to go into the repository. So this is my first commit at 14.15, and this is my second commit at 14.28, where I add new data received from Ryesos Biochem Lab to my data file. Okay, so maybe this sounds like too much. I really like to have, like, in some cases, several lines of comments. GitHub doesn't like that kind of. It tells you, oh, the pros don't write too long commit messages, and then has a description thing. I think that's BS. The longest you can write here is the more descriptive, the more information that you can have for recovering your changes. Okay. What time are we supposed to have the break? I'm going out of time, or we can? Okay. So we're going to do a couple more of examples. I'm going to show you something that is not in the slides, because it's something that kind of annoys me a lot. So what happens if I want to keep some files, and I think Francis was talking a little bit about this. What happens if I want still to keep some files in that directory, but I don't know any time that Git says, okay, you know what, that file, current dir, is not in the repository. Well, there is a way to tell Git to ignore that. Okay, so what we are going to say is, I'm going to say I don't want to consider the current dir file to be part of my repository. Okay, so I'm going to use a text editor again, so in this case nano, and I'm going to just write the name of the file, current dir, and I'm going to save it to something called .git ignore. Okay, so now I'm going to exit. I'm going to use ls-la, and now there is my test file, that is part of the repo. There is the current dir file, which I want to keep in that folder, but I don't want to be considered by Git to be included in the repository. There is the git.content file that I'm going to keep and probably add to the repo, and then this other file that starts with dot and says .git ignore. Now look at what happened now if I ask for git status again. Now it says, okay, there is a new file .gitignore, and then there is the other file git.content, but current dir is not shown anymore because I'm telling Git to ignore whatever file is included in that .gitignore file. That is kind of a pro tip if you wish, but I found it very useful because sometimes I want to keep crap in my directory, but Git not looking at it. So, questions? I think so. I think so. That's kind of an inception kind of question, but let's take a look. Oh, come on. Sorry, I'm used to use another editor, so yes. No. And we're going to do that. Git nor. Going to say that. Yes. If I look at my gitignore, should have 2 entries, current dir and gitignore. Hopefully I type it correctly. And now if I do git status, it says it's still showing the gitignore. Did I type it right? Oh no, sorry, that's the previous one. Yeah, no, it's not showing it. Yeah. It's like, oh, great. Yeah, that's a good one. Yep. Okay. Now I could do just git add what is the other one? Git content, and then git commit, and I'm going to say adding an initial image of how the Git repo looked at the beginning. As I say, the more you can type, the better. And now if I do git log, now I have 3 commits. Okay, and if I do git status, everything should be clean. Nothing to commit, working directory clean, everyone happy. Okay, and still if I do ls la, now it shows I have my current dir, which is not part of the repository because it's excluded in the gitignore file, and as well the gitignore file. Yes?
If you don't include gitignore in itself and for repository, is it going to commit gitignore and it's included?
Correct. And some people do that. Some people do that, especially when you are working in a centralized repo like GitHub or something, because you want like whoever is collaborating with you, don't put their crap in the repository. So it's a way to keep, you know. But this, as Aranzi says, Git is very flexible. It basically allows you to, you know, customize Git, the repository as you wish. Okay. Yes. As I say, it's a little bit of personal taste at that point. There is another way to tell Git what things to ignore, and that is in the config file. So if you do less git config, I think, I don't remember from the top of my head, but I think you can, so these are like different sections. When you start with a bracket, like core is the main core things, users are the users, then you can have like different branches and different repositories or things connected. I think there is a section, which I don't remember now, where you can specify what files to ignore there. So as I say, Git has a lot of knobs that you can change depending what you want to achieve, and this is one of that you can do in different manners. You can do this gitignore file, which I agree, I kind of agree, sometimes it bothers me to see a gitignore file in a repository, but I also understand that some people, so another way is to modify this config file, which is not visible to most of the users because people don't go and look into this unless that you want to change something in the configuration, but you can also do that. Okay. So let me see what else we have. So if we look at our status, now everything is clean as we saw. If we look at our log, we have 3 commits. Okay. And so let me do let me do one more thing. So, you know what? I'm going to one of the files we have there. Oh, the other thing is we look at the list of files. Now we should show the two files that we have: git content and test file. So let's imagine that now I want to add whatever was in the Git directory again to Git content. I'm not going to overwrite it. I'm going to just add because I'm using this greater than symbol. Okay, so I'm going to modify again one of the files. Is that I do git status now, it's telling me the git content file was modified. And we saw this before. If I want to look at the differences, in this case, because it only changed one file, I just can do git diff, and it shows that all these lines were added to the previous file. It all has a plus in front, so all those lines were added to the previous file. And the reason is, if we look at the git content file, it shows the two stages, right? And that was at the very beginning when there were only these files here. And now, because I had done way more things, I have this extra file that Git created for the commit messages, and then an index file, and probably some other stuff, that the logs file. So there are more files there. So that's why the git diff shows this. Okay. Now I can say, okay, let's add that file. Git add git content. And I'm going to say git commit. Yes. Yep. Let's modify. Oh yes, yeah, no, thank you. That's a great. So that, again, this is the two stages that we were talking before. I think we saw this one before, but now because we modify that file, now it shows in the git status. Before doing that, it was all clean. Now I changed one of the files, and now it's seen as modified. Right? So if I want to commit now, I'm going to do git commit and saying updating the list of files in the repo. Okay, and now my log has at least 4 commits. Okay, now let's say that I change my mind now, and instead of wanting in that git content file the latest version of the Git repository, I want actually the previous one. I want the one that I have originally, because if I want the current one, I can just do ls.git, right? So that is because I put my message here, adding an initial image of how the Git repo looked at the beginning. I can go back to this commit because I know that is the label associated with the change ID. Okay, so now this way, I think I had this in the slides. So yeah, so this is the recovering file versions. So if I want to go back, and let me go back to my diagram just to show this. So what I mean now is we have done 4 commits already, so we will be like here, but we want to go back 1 commit back. So I want to recover my previous version of the file. In this case, it's kind of trivial, right? I can just go and delete those lines and will be easy. But you can think, or you can imagine, this can be more complicated, especially when we are talking about codes or even papers, or even when more people writing on the same file. But I want to be sure that I just prune the last changes someone did because it broke something or because I don't like it. Okay? So what we're talking is like moving back to the previous timestamp in the Git track of changes. So how I will do that? So the way to do that is to use another Git command called git checkout. And what we need to indicate now is, let me see if this works. Oh, no. Sorry. I'm not a very good Windows user. See if this Ctrl-C works. You guys know how to copy things in Windows? Sorry? Not working. Control? M. Okay, so this is the part that is a little bit because this is the come on. Okay, so what you need to do actually is grab this thing in Windows. Control insert. Okay. Yeah. Shift insert. Yeah. I see Control B, Control Shift B. Okay, we need that thing, and I'm not going to write it, but we can try. So, okay, 7D9064 F6 C6 F9 178 35071 EA01 7D 3B. Oh, does it complete with that? No. You think that will be enough? Okay. Okay, so yeah, so the level is long enough, but you should type, I don't know how many of the first characters, probably 7 or 8. You recognize that and basically go back to that. So what is saying here is the head, which means the pointer to what is the current status of the repository, has been moved to this particular Git commit, which is this one which I indicate here, 760 blah blah blah. Okay. So if we do Git status now, it says the head is detached because I move my pointer to there. But if I look at that particular file, Git content, now it only has the content that was committed initially. Okay. Now this particular way of doing things also removes, or not removes, but it changes the pointer, so you don't see the fourth commit anymore. Okay. Now this is tied to branches, so there is a parallel branch. That's why it says the head is detached for the master branch, but it allows you to basically recover the previous version of the file. Yes. Oh yes, because it wasn't part of the repository.
Say first, second. Go back.
Yeah.
Say second. Wow.
Yeah. Yeah, because it's like moving in time, right? At that point in time, it didn't exist anymore. Now, the good news is you have a different branch where that thing exists, so you can go back to that branch. Oh, yeah. So, if we do git branch, so the master is where everything exists. It's in white. It doesn't show up like in different color, but now the star says detached from whatever. So, it turns out the Git basic functionality doesn't have like diagrams, but you can imagine this kind of very easily start to create like this kind of madness, timelines, flows, and I think GitHub or Bitbucket allow you to visualize that very nicely, and there is also a tool that allows you to visualize this.
Of the threads, that's the.
Yes, that's the current branch where you are in.
So if you want to switch.
Yeah. So we can do git checkout master, and that's the checkout. I think there was and now if we do git branch, oops, I need to know how to type git. Now we are in branch, we are in master, sorry, and if I do, I think I was playing with git content, it will show the latest content. So we went back in time and then we recover the current status by doing git checkout. So I'm going to put that the list of commands. So changing versions of files / branches. that will be git checkout, and it can be here it can be either the label of commit, or it can be the name, we put branch name. Okay, so git checkout is one of those things that are very, very useful. Yes.
So the master table, say, that always.
The master branch will always remain unless they just explicitly say, well, you can synchronize branches, but the master branch will always remain. If for whatever reason, and I have seen that happening, sometimes you can screw big time with it. As you start to play with the branch commands or things like that, it's very hard to recover something without a master branch. So you can actually try to remove the master branch, and that will be nefarious, I will say. Yes. Yes. So git checkout will change between branches. We can do that. I don't. So branches is one of the things I consider advanced, but because you guys are asking, let's do git branch. So creating a branch is very easy. You just do git branch and say, let's say new. Oh, okay. Yeah, we can show that and then do the thing. Oh yeah, I remember which one. That one. Yeah. So this one represents, I believe, the master branch, and then if you take out the two, so this is merging a parallel branch and then merging back into the master branch. But some of you were asking today, can I keep branches separate? I will say yes. I can show you actually an example. So this is how. I'm sorry, we are going off script here, but I think that's okay. So Leslie is going to show you today GitHub, but I use both, but I don't know why in this case I was using Bitbucket. But it has a nice tool that allows you to visualize. So in particular, this is a bioinformatics pipeline, and has this tool branches. Actually, you want to go to commits, and it shows you. So these lines here, for instance, that's my master branch, and then I have a test and development branch, as I was mentioning. But you can see that the dots at some point connect, and that is when I synchronize from my development branch to my master branch. So you can keep both live and communicating between them. So, yep.
Once how you say also.
Correct. Just so we're going to see that probably later today, but you can do git push and git. So git push basically takes your current image into your remote repo, and git pull brings whatever is in the remote repo into your local repo. So that's the way to communicate. Yeah, assuming he. Yeah, absolutely. Yeah. I believe that even if you have a Git in your local machine, GitHub or Bitbucket will allow you to import that repository and create the repository for you on the fly. I believe. I haven't done that, but I have seen that is possible. Yes. No. So those are parts of the branch. So right. You can do that. So I have. Did I put that? See if I put that. If I didn't put that, I can add it. So there is. Yes, here it is. So there are different ways that you can actually move around the time flow And the one I show you is Git checkout. And with Git checkout, you can do at commit level or a file level. What means is you can either check a particular commit or you can check a particular file. So if you want to just recover a particular file, you can indicate I want to recover this particular file from this particular commit and non retrocess or go back to the whole story at that point in time. Okay. Now that you mentioned that, there is the git reset, which also works at the commit level or the file level. Now, the problem with that, or not a problem, sometimes you may want, so that's why all this flexibility is embedded in Git. The thing with this is you are basically discarding any commits in the branches that have happened. So it's like I'm pruning my memory, basically. Alternatively, you have git revert, which undo a commit in a branch. This doesn't work at the file level though. It only works with commits. Yeah, sure. We can take a 15 minutes break if you guys want and reconvene like 3:10, something like that. Yep. And if you guys have questions or something you want to discuss, we're going to be around. So.
I honestly
think it's time to continue. Any questions from what we had covered so far? No? By the way, I put in slide 32, to be more precise, a summary of some of the commands that at least I found myself using more frequently. By the way, the complete list of Git commands you can get, as Leslie was mentioning before, with the man pages. So you do man git, or you do just git -- help. But I put include the ones that I use more frequently, like of course git add, we saw git branch, checkout. Clone is when you clone a repository from a remote repository, for instance. The commit, diff. Fetch is again for fetching objects from another repository. There is a grep, so if you are familiar with grep, you can also use git grep. Init we use at the very beginning. Log, merge when you want to merge branches or things like that. Move, so this is another one that is sometimes tricky. You don't know this one. If you want to rename a file, it's possible. But one way to do it, otherwise Git will complain, is to do git move. If you rename the file outside the repository, then Git start to get a little bit upset because it cannot find the file that it was called X before, and now you name it Y. And so better way is to git move X Y. Pull and push, we talk about that. Rebase, reset. I'm going to show you how to remove files. Git show is another one that is similar to git status, and git tag is a one that is very nice. And let me show you. It works very easily. You can basically give particular names to particular commits. So if I go back to my repo here, and instead of looking at the branches, where I have 2 branches, I can actually look at tags. And what I have done here is, in my code, I have a version 1 alpha and a version 1 beta, and then I will have a 1 release or something like that, or 2. So you can tag particular commits just by saying, okay, at this moment I'm happy with the status of my code development, so this is version alpha, version beta, whatever. You can do that, or you just can do git tag. So let's do that in the example. So let's say, and again, I'm going to mimic, this is a process of software development, so I'm going to say git tag, I think you need version 1 alpha, for instance. And now if I ask git tag, so that I know that my last tag is version 1. I don't know if log shows. Oh, by the way, there are a couple of flags that you can add to log that are kind of useful. One of them is a stat. So if you do git log stat, it actually shows you the different changes, give you statistics about the changes, insertions and deletions. And the other one that is useful, I don't think it's going to be very interesting in this case, is graph, because you see that red line here and the dots. So it tries to mimic that kind of branches that we have. So it can show you when you have diversions between branches. Yeah, the tags are moments in time, not necessarily associated with commits, but it takes all the previous commits up to that moment where you do the tag. So it's useful when you're happy with number of commits, so you can go to that. And you can also use for checkout the tags. So this is a kind of a summary. I think the only thing I'm missing from the slides in showing you is git remove. Okay, and as I say, let me show you an example. If I want to move my test file and I want to name it actually data file, I'm doing that in the command line with the mp command, and now I ask for git status. Git is going kind of freak out a little bit and saying, okay, you deleted the test file and you created this new test file. But if I don't do an add and a commit, then it will keep reminding me that test file was deleted. So let me move out my data file. Oops. What I have found is a better way of doing this is, let me go back to this. Git status is, did I rename it properly? Oh, I missed. Okay, so that's why. Test file missing one T. So now if I do git status, everything is clean. But again, let's suppose I want to rename this file to data file. So I'm going to do git move test file into data file. And now I just do git commit. So this is one of the few cases. The other one is the remove command, where you don't need to do the git add in advance. Okay, so I'm going to say renaming data file, and this is it. And then my git log has the renaming of the data file. My git status is clean again. Okay. Any questions about this? Okay. So git ls files will show which files we have here. We have the data file and the git content. So let's say that by now I'm not interested anymore in having the git content file in my repository. So one thing we can do is actually delete this file from the repository. So if I do git content remove, git remove git content, now git content is removed, and now I'm going to do git commit -m removing data with repo info. And now if I look at git log, so all my commits there, if I look at my ls files, the only one that is there is the data file. The other thing that one needs to be aware when we do this is that the file is actually deleted from the local copy itself. Okay, it's like you were issuing a remove command in the terminal. Okay, it's of course in your history of changes. So if we go back to whatever was the log or the commit where we were putting it, you can still recover it from the Git history of changes, but locally it's gone. Okay, it's in that box, white box that we draw at the very beginning, but no more in the current directory. Okay. Questions about this? Okay, and with that, was anything else I supposed to cover? I don't know. Sorry. What was that? Oh, we can do git revert. Yeah, sure. So let's say that actually by mistake I didn't want to delete that file, so I'm going to do git revert. So git revert, and I'm going to pick f69 e6 d5c. Let's see if that is enough. And now, because this revert, let me show you the slides, basically works at the commit level, but also is undoing. It's like you are actual undo in the text editor. Now, because it's doing that, it says, okay, this is going to revert to that, revert whatever, and it's asking me to commit this as a change already. Okay, so I'm going to say, okay, commit whatever. I'm going to write this, and then Ctrl X, and that's my commit. So if I do git log, now revert renaming, that's my last one, and if I do ls, my files are there. So it's called test file instead of data file as before. Okay. We did the git checkout. The git reset, as I say, it can be tricky, but it works in a very similar fashion. So if we do git log start, now this is our last commit where we revert the renaming. We still have the remove of the file. So if you want to reset to, let's say, 77, let me try that. Is reset 7ff3e41. Okay, so what it's saying basically is the previous commit was when I delete the Git content, and basically is unstaging those changes. So now Git log. Oh, I had to do Git pull, I believe. Oh, this is not a public. That doesn't mind. So let's see if we create a new branch for that. Still, what did happen there? That should have gone to the previous. That's it. Okay. Oh, git commit. Right. So I still need to commit this as a change, right? So resetting to previous commits and 7ff3a41 something, and then it's not taking my reset. Sorry? Yeah, I don't know why it's not taking my reset. But this is one of the things that you can mess up with Git a lot. I particularly what I use usually is the revert or the checkout. The reset can be tricky sometimes, as you see. I don't know, maybe I misspelled something in the, let me see the logs again. Which it was saying 7ff341. Oh, okay. No, it did what I asked, right? It pulled my pointer. So this is what happened with git reset. Let me show you in this diagram. So with git reset, it basically puts your pointer back to whatever is the commit that you specify, and that is what I'm seeing. So I lost track of whatever happened before. So you can undo the reset, but somehow one thing I always recommend is to keep the list of the previous labels of the commit. So I can try, let's see if that works, to go back to my earlier commit. Which was A951DA79. See if I can remember that. A5 895
895.
1D, something like that. Okay, let's see. Yes, great. So that's the trick. You need to keep those labels. So if you're going to play with reset and revert, I would recommend that you do something like git log stat graph. All those labels you don't need, but something like my git.log. So you keep track of those things. So there is a my git.log somewhere there, and you can go back to all of those without losing your history in time. What else? So let me add those commands to the list of ones we talk about. Actually, not going to add the reset and revert. Well, let's do that. Let's do reset and git revert. And there was a couple more. Oh, so for git log, there are two flags that you can add, which sometimes are useful: stat and graph. We did git remove, git move. That one is very useful for renaming files. What else? Check out. Yeah, I'm missing something. Let me see my history here. So that's another useful thing that you can use in Shell. You can ask for the history of commands that you did. I think that's a set. Yeah, before were the branches. Oh, the tags. That's the other one. So for branches, we did git branch. That shows the branches, and then git branch a branch takes you to particular branch. Sorry, git a branch, new branch creates a branch. And then git checkout change the branch name. That one is just above. And tags. So that's the other one. Tags, just git tag. I think that's more or less the commands we saw today. I'm missing something. I think that's what we have so far. Any questions about it? Yeah. Mm-hmm. No, so again. No, that's not a branch. That's just moving the pointer to that thing. And then git checkout to then the branch. So if I do git branch here, it says just master, but I can say git branch, test, and development. Now, if I do git branch again, it shows the two branches, but now I can say git checkout, test, and development. And so now it switches to that branch. Yeah. So now the active branch is that one. So I see what you're asking. So what will happen when you do git checkout a commit is a parallel branch is automatically created because it's detached from the master branch. So at that point, then you have different decisions that you can take. You can decide either to keep that change and that be your master branch. So you need to basically merge that into your master branch, or say this is my master branch from now on, or you can not name that a particular branch and then keep in parallel and synchronize, merge them or not. So it's up to you what you do at that point. Correct. The master will stay. Yeah, that's right. Yep. Lowercase, right? Triplet? Okay.
When you have different branches,
Oh yeah.
well, we'll show the last name. So say, for example, we have an old branch.
Mm-hmm. That's another thing you can do in the config file, create a lot of alias. If you do git log graph, it should show when you do the next commit that the two branches bifurcated, and as Alexei was saying, if there is one ahead of the other one or something. Yeah, that's quite useful. Any other questions? One thing I think we forgot to mention, don't forget to sign the attendance sheet so we can then give you credit for the course. I think that's all what they have so far, so maybe Leslie can take over for the GitHub and then we can do more questions after that.
Does everyone, so it seems like you guys are pretty like comfortable with Git. I'm assuming, do all of you have GitHub accounts already? No. Okay, so I just wanted to demonstrate how you can link your local repository to a remote repository, and GitHub makes it like super, super easy. So I would encourage everyone to go to github.com, and you can make a different, so you already set up your configuration when you set up Git, and you set up a global username and password. And when you go to GitHub, you can either use that same username and email address and username, or you can just locally set your configuration in Git and to whatever it is in GitHub. They just need to match to talk to each other. This will all make more sense once I plug in. One second. Okay. I'm already, sorry. Isn't it? Hello. So if you go to github.com and you can make an account. So what I was trying to say is that however you configure Git on your machine, you can make a local configuration just for this exercise. So you can use whatever you want to make your account.
Or we are having some technical, you're missing one sector of the screen. Oh, okay. I was unexpected.
This is really funny though.
I know. I pressed the wrong button. So. Okay, it will take 5 minutes or so. Sorry.
Anyway, so while we're here, GitHub is like, I don't know, I worked in an IT department and all of the developers use either GitLab for private stuff or GitHub for open source and public stuff. And to me, GitHub is, you know, in academia and libraries, I work in a library, for most open source projects, everyone keeps a copy there. So it's a really popular, it's almost like, to me, it's like this, it's like almost a social site for developers, especially in the open source community. So I would encourage everyone who wants to share their code or wants people to read their code to have a GitHub account and share what you have. And it also is an opportunity for you to contribute to other people's code bases and interact with them. Because as you'll see, there's a graphical user interface for a lot of what's happening in Git. And it lets people comment on changes you might have suggested. And it's a really nice way to interact with people on projects like that. I personally, maybe it's like my personal association with open source projects. That's my association with GitHub. But I know people are using it for all sorts of reasons. And if you pay, you can have private repositories.
Maybe just how to fix this thing?
It's rather free.
Pardon?
Microsoft bought it, so now private repository.
Oh, now is private free now? Oh, delightful. Okay.
Yeah,
It used to be that you had to pay for private. So anyway, now you can use it for whatever. I think the fact that public was always the free option is part of why it became like the place for open source folks. It's really easy to connect your local repository to GitHub. And
We're almost there. Hopefully. Cross your fingers.
so
I don't know if you mentioned this while we wait for the screen to come back, but it's also a really good thing to put in your resumes. So you're
yeah,
applying for jobs.
definitely put it in your resumes. 100% put it in your resumes if you're applying for a developer position and have code.
Just the URL if you didn't.
Pardon?
Provide just the URL if you need one.
No, put your account, like your GitHub handle. I would put that in. I can 100% say when I'm on the committee, the
broker.
Well, I tried the
Something else
view.
that also like updated that some of the ones that I've done for example.
Put in
I
3%.
so then I don't really have like
Yes,
As
no,
a
okay,
you don't
we still
have
need it.
current
Yeah,
stuff.
so it's not-
So maybe taking
Like,
the projector
obviously,
down is
Yeah.
case
actually
studies.
Yeah,
because
it's
otherwise.
And if you want to
yeah.
showcase your work,
No mind,
I would-
but that is something you have
like
to
honestly, as a
reset.
professional decision, if you want to showcase a piece of work,
That's
upload
good.
this work, and then give them your handle, or just don't include it if all you have is outdated stuff. But if you have stuff you want to show, then it never hurts to do that.
It doesn't even matter if they want
Turn off the,
Well, before it was doing it automatically, so
Yeah,
sure,
I mean, it's,
Down.
obviously it's always a choice.
down, yeah.
Like, don't do it if
Right.
you don't think it's gonna help your voice.
Well,
But
Yep.
if it is like a place for you to show what you can do, what you have
Yeah, it's
done,
okay.
and especially, I don't know.
There you go.
If
Well,
you
I
want
can
to
knowledge it to the
share
rest.
their own open source projects, and that's something you want people to see, then that would be a nice thing to share. I mean, it really does depend on the situation.
Sorry, we came back to old terminology. We were having some apologies.
Anyway, like, I mean, there's always, there's always like a social element to it, and it's up to you to make those decisions on like how you want to frame it.
Just to mention and to make contact what we did earlier before, that description that says optional was the description file we were basically touching in the .git hidden directory. So it's basically a mirror of what you can do in the terminal, but
Okay, so if I'm still in my terminal, so I'm logged into my GitHub account, and I just clicked on make a new repository. You should see like a green button. And I'm just going to call this what I called on my thing. And GitHub like makes it ludicrously easy for you to be able to link things up, because when I do this, it's going to gives you the code. It gives you the code to be able to link your local repository to your GitHub repository. So I'm just going to copy and paste this, but let's talk about what's happening here. So each of the, what I do want to point out is that origin, origin is a nickname for the remote repository. That's what we're doing. Like, we're giving an alias for our remote repository. You could call it anything, it's totally arbitrary. Traditionally, people call it origin. So that's what you're going to see most often. And this, when I press return, basically just creates a connection. I'm basically saying my local repository with its current configuration. And if we want to see what's happening, my current configuration, which are global settings, like I signed up with the same username and email addresses I was using in my GitHub account, are here. Sorry.
you can do command plus.
Command plus.
And if I go git remote v, I'm basically saying be verbose about the situation, and it's going to tell me where I'm connecting. So I've just established a connection with that repository. So you could, hopefully you have a couple of text files and you've made a commit. But I have, like following along with the previous demonstration, I have not committed this, so I'm just going to add git. Okay. So I've now committed. Everyone has made the mistake where they try to push something to a remote repository without locally committing first, and then we forget that that's the thing we didn't do. you have to make a local commit before you do that. It's like always easy to forget these steps. So we have the local repository, and we have the remote repository, but it's obviously empty. And so what we're going to do now is we're going to push from our local, what we have in our local repository, to that remote repository. So the command for that is git push. And then one of the options is U just says, remember the local parameters I've already told you. So you're never going to have to put that URL in again. Just like remember this stuff. You're saying remember it for future reference. This is the relationship between this repository, this local repository, and that remote repository that's living on GitHub. Origin, which is the nickname for our remote repository. And then master. Okay, so oh my God, please. No. Pardon? Oh, it is asking me to, okay. That's right. There we go. It asks you to do that, and then it stops asking you to do that because it remembers your credentials. And I forgot that was going to happen. Thanks. And there it is, right? And if I were to make any subsequent changes and commits in my local repository, I could just write git push, and it would like go there. We've already told it what the parameters are. We've already created that connection. So as long as you want to, you can just keep pushing to that public repository. If you want to pull stuff, like let's say you made a change or someone made a change and you accepted their changes, and you want to pull those changes from your GitHub repository to your local repository. So we've already created this connection, so it's actually quite an easy thing to do. So I'm just going to make a change here. I'm just going to make a README file. And I'm going to commit that file. So we're basically doing the same thing we were doing in our local repository. You have to make that commit before we're going to move things between a local and remote in either direction. And then I simply wrote git pull. So we've already put those parameters in. We did that earlier when we established that connection. And so now when I write git pull and just that command, it just pulls it in. And now we can see that that README file has appeared in my local repository. So it can work in either direction. And I feel like it's a really easy way of making those changes happen and of connecting yourself with public repositories. This is obviously much more powerful when you're collaborating. And if you say, I want to make a branch, I want to make a local branch, and then start pushing things back, like it can get quite ornate, but it is actually relatively easy to create those connections. We don't really have time for it, but one thing I did want to talk about, mostly because like I'm really, really dense about some things. It took me a really long time to understand the vocabulary of pull requests. Everyone's probably going to be like, yeah, we already understood this. But it took me a long time to be like, no, you're asking them to make the pull. I was like, why are we calling it a pull request? I'm pushing this to them. What's going on? And it's like you're asking them to pull your stuff. So that's kind of part of the social aspect. When you make a pull request, if you're making an edit on someone's code, you're saying, hey, like, I made these changes, I think it fixes this bug or improves this feature. Will you consider it, please? Will you pull my changes?
And then if they pull those changes, they're like, yeah, thanks. And if they don't, then that's a thing that happens in everyone's life. But that's the reason why it's called a pull request. Yeah, that's the kind of like dense thing. Takes me a really long time to get with. But that to me is really part of the social aspect of GitHub. And on open source projects, a lot of development really happens through that kind of participation in pull requests. So I wouldn't overlook it. Like there can be a lot of public commentary, and it can be a really great way to learn. So I think even just browsing GitHub can be a nice way to like find new code to play with, or just like clone a repository locally and just have at it. Because it's people who are willing to share their code with you, which is kind of a great thing. Are there any questions about setting up those simple relationships? Yeah.
If you have multiple email addresses, for example, if you want to start switching over to a different one, can you connect multiple ones with your GitHub?
Yeah, so you can, so yes, you can have multiple, obviously you can just like do what everyone does in life. You can have multiple email addresses and multiple accounts in GitHub. But you can have your global settings, and then just like in a particular repository, have your local settings.
Okay, and on GitHub you can add a bunch of email addresses?
You can have multiple email addresses associated with the account, but I think you have one main, like there's one canonical email address for that account.
But you can still connect it if you're using it.
I actually don't know the answer to that. Like I don't know if you can switch between.
Are you looking for receiving email notifications, or actually being able to commit as different personalities to say so well?
Just committing, like if you want to start switching over to, let's say you work with a few different machines and maybe you use.
Oh yeah, that you can do. So the way you can do it, and the way I do it, for instance, is I don't use my user. I use SSH keys.
Right.
So you copy an SSH key that belongs to the Git repository, and then you can have different users and different accounts, or even different users within the same computer, but with the copies, local copies of the repository in different places. So the authentication method is different. So she wrote her username and her password, but instead of doing that, it's a little bit more involved. So you need to copy, but there are some guidelines in how to do it in GitHub, and I can send you the guidelines. So you basically need to copy. It's what it's called a public key from GitHub. You put that in your SSH key, that is the protocol that is used to connect to GitHub and to me, and then you can actually be whatever user you want. In addition to that, you can also have like different email addresses for the notifications are sent, and that you can even do in your local repository, in those config files that are in the .git.
Right, so I guess I'm a bit confused about how the local user, when we set the config username and email, and then how that relates to GitHub.
So that relationship, I believe, for the local repositories is one-to-one. So you cannot.
But you can have, okay, so there are we're using local in two different contexts, confusingly, sorry.
No.
So for our Git config, we have global configurations, but you can have local configurations for a single repository. So you can set like a new username and password for a single repository, just by not using the global flag.
Mm-hmm.
So when we added that global flag, we're setting this up for Git everywhere on this computer. So you can change your config values for that local repository. So you could conceivably run like 3 different repositories with 3 different configs, and those would supersede the global configurations.
Right. So sorry, I didn't mean that local. I meant your computer, your own computer, versus the credentials you use to log into GitHub. Like, do those need to match the email that you use on your Git config and email?
If you did as Leslie did, if you do as Leslie did, then yes. But there is another method that is with the keys method.
So if you're using HTTPS, yes.
Correct.
If you're using SSH,
Even if you had a public repository, do you create a public or a private?
I mean public.
So the public one anyone can join.
Right.
So, you know, like you just go and if there is a button that says clone it or download or whatever, you just clone it and it doesn't care at all who you are because it's a public domain. Right? So I don't know if that was.
Mostly, I think maybe I just
Sure,
paused
sure,
it
yeah.
about the.
Yeah, if there is something specific.
On the push request, I got a message saying your push will publish a private email address. It's an error on the website.
What was the error again?
It said it was going to publish a private email address. There are, GitHub has like pretty sweet instructions for keeping your email private if that's something you want to do and that concerns you. But I've never encountered this situation.
Oh, that's it. So the private one is kind of what we were talking. He was using a private.
Oh, gotcha, okay.
Yeah, in the public one, the private, there are some credentials issues there. And then you need to allow the keys from GitHub. Basically, that's match. So that's another thing. Some people, so I don't know how many are using this nowadays, but there is a way to set up central repositories using GitHub in your own computers. You don't need to use, sorry, not GitHub, Git repositories in your own computers. You don't need to use GitHub if you want to be like very, I mean, let's say hospitals, right? They are very picky about privacy. So instead of using GitHub, they may use their own networks for setting up their own repositories. So there is a way to set up their own repositories, your own private repositories. Some people, what they do, for instance, is they create a GitHub user where it basically connects to the repository and then the authentication is done through SSH keys. Or you can do misusers, right? So it's up to how you configure the Git repositories.
Yeah. Are there any other questions for either me or Marcelo?
I was going to ask, say you have one laptop and you're working on local copy, so you're using Git for that. Now let's say you want to copy that code over to a totally different machine. So if you say use it via UofT, I guess you would have to copy the Git folder as well onto the other one. Otherwise, it would not be able to achieve.
You won't, yeah. But you can copy the whole directory with that hidden directory log Git, and then you have the whole layer of the same thing on the side.
So if you did any change on one computer, let's say the Git like repo changes on one side, then you would have to copy the Git repo folder to the other one.
Right. The difficult part here is you do, so now you have two different repositories. So synchronizing them, I mean, okay, the only way it will work is that you are sure that you always change one copy at a time and you automatically override the other one, because otherwise you won't be able to match both. Alternatively, what I would suggest is use one of those as your central repository, create a server. It's quite easy. I didn't put instructions because, again, it's kind of the advanced Git thing, but it's quite easy, especially if both machines are in the same network. You don't need to have anything fancy set up. Yeah, right? Meaning if one of the machines or the machine that you're going to use as a server is reachable from the internet, it's very easy. Yeah, absolutely. Actually, you should, I don't know if everyone's interested in that. If not, you can. I can put a link to another slide I have where there's a slide that explains how to do that.
Well, I have two laptops, so sometimes when I do it, it's copy that goes from the Levana to the Assist, but I'm wondering like.
No, yeah, probably that's.
I could just SSH them.
Right. If you can SSH into one of those, then you can use that as a server. You're good to go.
But for the one that's just gonna be like, just like a
Pulling,
backup
you
copy,
will be
just
basically pulling from, yeah. And that's the other thing, I use sometimes I use the Git repositories as my backup, right? Like I'm developing something and it can also be used as a backup, because especially if you have like distributed copies, distributed versions of the repository, if one of the computers goes down, the other one has your repo there as well.
Yeah, but I have to do it with the UofT. So when I do a Git pull, say from the backup to the main laptop, through SSH, then essentially by that point, I don't need to have a USB, all the changes that were in the master will go to the second.
It will be everything, yeah.
So, because they'll just read the config file with those changes and just update it.
Yep.
Just wanted to ask, like, best practices. If you, I've never worked with GitHub, but if I wanted to start working on somebody else's code, or like somebody starts working with my code, they'll make a branch on GitHub and work on that branch, and then try to make me pull, like if they suggest, hey, this can help you, they do a pull request. They're
Yeah.
asking me to pull their branch and merge it with the master branch on
Yeah.
GitHub. So, is there a way, can you download just the files that they?
Yeah, it's just a clone.
Okay.
So when the difference between forking and forking is like you kind of still keeping a relationship with their master branch and basically making a branch. Cloning, like if you don't anticipate working with them or asking for anything like that, you can just copy everything, and that's the clone.
But like, let's say that they work on, like they branch your master, and then they work on some files of that, the head of their branch. Can you just download those documents without having to merge your branches, so you can take a look at their changes and play with the code to make sure it works as they claim it is before you do like a pull?
Well, when they do a pull request, you can see what they've done. You can see all of the differences and all of the changes they've made, and you don't necessarily need to accept everything, but you can definitely see it and like work with it. Like there's like when you do git diff in your own terminal, they basically have an interface that shows you essentially just that, all the things that they've changed. So it's not like, it wouldn't be mysterious in that regard.
So that's one way, just checking, but if you are asked them to actually execute it, what they change and prove it, what you can do is actually add that branch and don't merge it with your master branch or your development branch. So you can add that branch to your repository, test it, be sure, be certain that it's not, screwing anything in your code, and then if you are happy with that merge, switch it. It's kind of the same idea of this test development branch and your master release branch. The only thing is that for a third party, right? So you can add that branch.
If there are no more questions, I really want everyone to just, if you could take a minute, we have a quick assessment form. It'll really help us as we move forward to improve the class. Figure out if there are topics you really wanted covered that weren't covered, or questions you had that weren't answered. It's not mandatory, but we greatly appreciate it. And we're not asking for any identifying information, so don't feel shy. All right, thank you for coming up.
Going to just post
What?
Oh, I see, yeah. But this was like important.
By the way,
Can you integrate you have a try stuff.
I've never tried. The one that I've done is-
Yeah, that was really fun. That was like brilliant.
So what I do,
Affiliate pay.
what I do, I use them. So
Oh,
I
yes,
think
yes.
my thing
I'm
is like,
taking care of them.
if we taught this for social scientists,
So I
it's
just-
very clear that almost everyone here is quite comfortable. Whereas I definitely taught that people like this was like
But I
hard.
only do
Yeah.
that.
I don't know if like it's just assumed that
So I have two laptops, one is a backup, one is my main one.
Right. So I'm going to post this slides. I don't know how much bigger.
Do you know what I mean? Like, it would be interesting to see.
So essentially, one of the two laptops,
Like just install it.
Like sometimes that's really hard, but everyone seems to seem like.
I'm surprised that, like, because I was surprised to pick up
Really?
Yeah.
I mean, I cut pull requests out of my GitHub thing, so it's just like, don't have
you
time.
create a repository, so you.
And it's also like there's such an emotional barrier by pull requests, right? It's like,
Yeah, exactly.
yeah.
So you don't need that. And then in your local machine, you do what you
Yeah, no, I
remote
think-
your repository, so you remote add, and then the thing that, so this
What we should probably do is like wait
add
for people
origin
to
and then your
hopefully
username,
assess.
your computer, and then
And we should do another one that
No,
like
this will do it for you.
be clearer about audience. Like how it
Right, so this is like, this is
Yeah.
expert and how to start with.
This is the one that you're going to.
Yeah,
This is
and I
the one
agree.
that
This
should
is,
have, this is the
I think the intent is to be more introductory.
And
Yeah.
in this example, what I'm doing is, I'm using the user key.
I think we got interesting for this audience because we did branch.
But I was like my entire lesson plan was super basic.
Yeah.
And it's like, yeah,
Well,
for a super.
you
for a
write
beginner,
whatever is
for
the
that
user
would be
at the name of
great,
the
but it's to make sure that
Yes,
the
and
right
then the name of the project, that in this case is assuming that
Because
this
nobody
is
seemed to have issues with finding their files.
you just write
That seemed to be-
Yeah.
I mean, we don't know. We'll have to wait.
Just us to synchronize.
I'm really excited for the weekend.
Are you?
Just saying that. Yeah, I am. I am.
You have plans?
I'm going to a family friend's wedding tomorrow, which is like,
Okay.
it'll be fine.
You don't need the push, but you need them to add, so in one of them you will need the push to synchronize
I think it's
them.
going to be
Either in the servers or
depends on how, but they are, right? Yeah.
Like a whole thing.
Yeah.
It's a social, it's like a pull request.
Exactly. No, you don't need anything else, and if you want to have more versatility, like don't be asking. So this will ask for your password, the same way that SSH does. Okay? But if you don't want that, you can also add keys, like SSH.
I
Yeah.
feel,
You can remove the key, the password if you
No,
want. So that's
well,
another
I
option. I
think the
don't like that
whole
because it's kind of a
concept
security.
is
So,
kind
I mean, no, exactly. Or you could even create a Git
Because
right?
it's-
Well, what happened was.
Yeah, oh, you
usually
can
they
just
don't put
format
the password, so
it.
that's
You don't have
very
to do
easy.
anything.
Kind of
But,
tweak.
but it's also something that is specific to GitHub or at least the, right?
So that would be the IP
once-
address
even
of
if you
your-
understand Git perfectly well,
And
now
as I
this
say, you can
whole
do it in the
request
local
is
network,
strange,
right?
because
Even
you
if
just
the computer
pull
is
and push
switchable
from
from the local
that's,
network.
aren't we collaborating? And so it breaks the collaboration zone, right? There is a,
There you go.
and I understand why, because you can't just have, right, it's sort of a quality control kind of thing. You want your stuff to be checked by somebody.
Yeah.
Yeah, but London.
Yeah, exactly. No, it's all what you need.
Of course, you're totally free to just keep developing your own.
And then you can even create
right?
multiple
And,
copies, right? In other
purpose, right?
computers.
But-
So again,
Yeah,
this
no,
door,
I think
your
it's,
user and the server,
and I don't know if
whatever
that's
IP, and
something,
then the name.
I don't think it's something you can,
Yeah, that I
it
use
is
a
something
lot.
you can.
And that's by doing this,
Yeah, like there's, like, collaboration is great, but unless you're like a naturally well-oiled team that are already working, imagine collaborating with somebody that you don't know at all. Like, there's trust issues, that's why all these things exist, right? And it's natural, and but it's also intimidating, like asking someone, like, once you know they have to give permissions, like, doing a pull request is like scary, it's like,
it is.
right? Like, it's scarier than just putting your code out there, so
Yeah,
it sees it,
Oh,
sees
yeah,
it.
of course.
And if you have any
Of
troubles,
course.
send me an email, we can.
But also, but it is, yeah, so I don't know.
So it's
if it fits
the same
into
one that they sent,
this
put in the.
setting per se, but it is
In the example,
important,
yeah.
I think, to realize. Why this is
No,
a social
endpoints,
thing now, is to say, there's humans involved, right?
Yeah.
Right, before we were talking all technical, right, this is the how-to, it's a good best practices, and now suddenly you want your code to be incorporated in somebody else's code.
Yeah, I guess.
Yeah.
It's all oriented.
Okay,
Yeah,
I'm in
I
this.
just tried to cut
No,
it's fine.
it's
Yeah,
not.
you saw my copyright.
Yes, that's what I see.
Okay.
Yeah.
That's why you're so complimentary. Just pointing fingers.
I've done SSH before, but I did it for after twice.
From the-
So, I mean, if you have any troubles, just send me an email, we can.
That's what I see.
Okay.
Okay.
I just completely.
Pardon?
Yeah.
Can you work on private repositories?
Last year I had.
Private, yeah.
Yes, you can have like,
Oh, yeah.
and like sometimes,
It's funny because I was thinking at Oscar, which were like selling them
Now.
for $20.
I know.
some places will have a local server like GitLab that they're running.
I think it-
to
It's
keep it really private, but open to the team. Like GitHub is kind
Just scroll
of
to the
a
past,
little
but
more
most of the
public,
material is the same.
but there are other solutions for, like especially if you have proprietary stuff or something you really don't
Hold
want.
on.
Because the stuff is on somebody else's server, like,
Yeah.
even if it's not, like, they could see your stuff,
Yeah.
right?
Okay,
Okay, thanks.
So if you
It was
really
actually pretty
want
good. It was actually really
that
useful.
kind of privacy, I would go set it up on the
Right.
server.
I'll try using it if I have any questions.